Hi there, this is Professor Shannon Gracie. Today we'll be talking about partial fraction decomposition, which is a very useful tool when you're in calculus later on. So basically, you look at four different situations when your denominator has non-repeated linear factors, repeated linear factors, non-repeated irreducible quadratic factors, and/or repeated irreducible quadratic factors. I guess you can't do an and or on that. So you either have, non-repeated or repeated, and they could be linear or quadratic. So here we go. Let's warm up. I just wanted to kind of show you what you're used to doing and what we're going to be doing. So here, go ahead and add these two rational expressions and pause the movie, see what you get. Okay, let's see how it went. So we have 3 over x times quantity x minus 1 squared plus 5 over x minus 1. Now, that is equal to, we want to get one happy fraction. So do you see that the common denominator is x times, great, x minus 1, the quantity squared. So we're going to need to, the 3 is good to go, but the 5 is missing what factor or factors? Great, it's missing x times x minus 1. So this will give us a result of 3 plus 5x squared minus 5x all over x times x minus 1, the quantity squared. Writing it in descending powers of x, we have 5x squared minus 5x plus 3 divided by x times x minus 1, the quantity squared. So first of all, how did you do with that? Great, I knew you could do it. Now, basically, we're going to go from what we just got, that when I boxed that answer, we're going to go from one happy rational expression to a sum or difference of 2 or more. So that's our job for today. So here's our first case where we have non-repeated linear factors. So basically the q they're referring to is the q of x in the denominator. So we're going to assume in the first case that there's non-repeated linear factors. So q of x would end up being x minus a constant, let's call it a1, times x minus a2, another constant, and then you'd keep multiplying until you got to your last non-repeated linear factor. And so no two of the numbers a1, a2, down to an are equal, because otherwise you'd have a repeated linear factor. So in this case, the partial fraction decomposition of p over q is of the form p at x over q of x equals a1 over x minus a1 plus a2. Some people just use a and b. It depends on what you like. X minus a2 all the way down to an over x minus a sub n. And what we're trying to figure out are the a1, a2, all the way down to an. So here we go. This guy is already factored, okay? So what we're going to write the partial fraction decomposition of this. So the first step is to recognize that these are two linear factors, and so we need to set it up in this form. a1 over the first factor and then plus a2 over the second factor. And then the other trick is keep this going, this fraction going. Eventually what we're going to do is we're going to equate the numerators once we get the same denominator, which will be in this step. So basically we need to get common denominators. So we're going to be multiplying a1 by x plus 2 over x plus 2, and a2 is going to be multiplied, nope, I lied. To get common denominators, this one will be x minus 1, x minus 1, and this one will be x plus 2 over x plus 2. I'm just getting a common denominator, just kind of like what we did in the warm-up. So then what we'll have is we're going to have a1x minus a1, I'm distributing that through, plus a2x plus 2a2 all over x plus 2 times x minus 1. So now that we have the same denominator, we can go ahead and equate the two numerators. So here's, the trick. Any missing terms, you need to add 0 with that term. So 3x could be thought of as 3x plus 0 because there's no constant term, and the highest degree I have in this numerator is x to the 1. So now what you want to do is you want to factor out an x on the right. So the terms that have x's are the a1 times x and the a2 times x. So we could factor out an a1 plus a2 times x, and then the other terms are constants. So we'll have plus negative a and then plus 2 times a2. Okay, so far? So we're going to equate a1 plus a2 to 3 because both of these are coefficients to x. And we're also going to equate the constant. So these are constants, so they have to equate to this constant. So now it's kind of weird. Instead of solving for x, we're solving for the coefficients to the x's and the constant. We're solving for the constant. So what happens is we end up having a system, of equations that we solve. So equating the blue, we're going to have a1 plus a2 is equal to 3. And equating the yellow, we'll have negative a1 plus 2 times a2 is equal to 0. And so this guy is a relatively easy system of equations to solve. If you add them, do you see the a1s will zero out? We'll have 3a2 is equal to 3. So a2 is equal to 1. And then we'll have, let's see, is there 2 A2s in there? Yeah, okay. So then we'll have okay, so A2 will be equal to 1. And then now that I got A2 equal to 1, I can take a look at the next step, which would be look at the top equation, and I can say A1 plus A2 is equal to 3. And then I would get A1 plus 1 is equal to 3. So A1 will equal to 2. Good so far? All right, awesome. So now, believe it or not, we're going to be done. We found A1 and we found A2. So what we do is we come back up here and we say, actually, we'll just do it down here. So what we found out is that 3x over, what was it, x plus 1, x plus 2 times x minus 1 is equal to 2 over x plus 2, and then plus 1 over x minus 1. And then we're all set. That's your answer. All right, so here we go. Next up, this guy, you have to look at it carefully. So what did we find out? We have to make sure everything in the denominator is factored, and we leave the numerator in general form. So good. I'm hearing that this one is equivalent to x squared minus x minus 8 over x plus 1, and you can factor x squared plus 5x plus 6 as x plus 2 times x plus 3. So now I see that I have x plus 3 right here. I have 3 non-repeated linear factors. So just go over here, a1 over x plus 1, and then plus a2 over x plus 2, plus a3 over x plus 3. So you guys go ahead and start working on a common denominator, and pause the movie and see how you do with that part. Okay, let's see how you did. So we have x squared minus x minus 8 over x plus 1 times x plus 2 times x plus 3 is equal to, so I'm going to go a little faster this time. Our common denominator is x plus 1 times x plus 2 times x plus 3. A1 is missing the x plus 2 factor and the x plus 3 factor. A2 is missing x plus 1 times x plus 3. And then A3 is missing x plus 1 times x plus 2. Okay, so now that we have the same denominator, we can go ahead and equate the numerators. So I'm going to write this as 1x squared minus 1x minus 8 is equal to, so we're going to have a1 times, I'm going to multiply out those two binomials, and we'll get x squared plus 5x plus 6. And then a2 is going to be multiplied to x squared plus 4x plus 3. And a3 will be multiplied to x squared plus 3x plus 2. Okay, so far? Awesome. So we have 1x squared minus 1x minus 8 is equal to a1 times x squared plus 5 times a1 times x plus 6 times a1. And then we'll have plus a2 x squared times x squared. That's sloppy. Here we go. And then plus 4 times a2 times x plus 3 times a2. And then we'll have a3 times x squared plus 3a3 times x plus 2 times a3. So now we have x squareds, we have x to the 1, and we have constants. So 1x squared minus 1x minus 8 is equal to. So we have an a1x squared right here. We have an a2x squared, and we have an a3x squared. So we're going to write that as a1 plus a2 plus a3 times x squared. Whoops, x squared here. Okay, so far? So this guy, and this guy are this. And then now we got to put together the coefficients to x. So we have 5a1. So these are the x terms. And we have a 4 plus 4a2. And then plus 3a3. Those are all times x. And then the constants are what is left, so 6a1, 3a2, and 2a3. So plus 6a1 plus 3a2 plus 2a3. And those were our constants. So now, here we go. Again, we're going to, these guys, this one will be equated to the coefficient of in front of x. This one will be equated to the constant. And then this one here will be equated to the constant in front of, or the coefficient of x squared. So here we go. We end up with a system. It's going to be a little bit complicated, this system. That's okay. We'll have a1 plus a2 plus a3 is going to equal to 1. So that takes care of the green. Then we have 5a1 plus 4a2 plus 3a3 is equal to negative 1. And we'll have 6a1 plus 3a2 plus 2 times a3, and those are equal to negative 8. So since we already have, letters in this equation, why don't we name these equations, I don't know, I guess 1, 2, and 3 for equation 1, 2, and 3 as we're working things out. So let's see. First up, we have to figure out what we want to eliminate, so it doesn't matter. We might as well just eliminate the a1 twice. So here we go. Negative 5 times, well, you know what? I'm just going to go ahead and do it. It's a little bit complicated with the notation I have to break it down as much as I did. So the first step I'm going to do is I'm going to take negative 5 times the first equation, which will give me negative 5a1 minus 5a2 minus 5a3 is equal to minus 5. And I'm going to add that to the second equation. And then we will get the a1s will zero out. We'll get negative a2 minus 2a3 is equal to negative 11. So we'll keep that equation in mind. And we're going to do another elimination of the a1 variable. So now I'll do the first and the third equations. And I'll have to do negative 6 times the first equation. So we'll have negative 6a1 minus 6a2 minus 6a3 is equal to minus 6. And then we're going to be adding to that the third equation. So again, the a1s will zero out. We'll have negative 3a2 minus 4a3 is equal to negative 14. So now these two equations that we have created, we're now going to add those together. So I'm going to have to multiply this equation here. I'll go ahead and I'll eliminate the a2 variable. So I'll multiply this equation by negative 3. So our third step will be, I'll get 3a2 rather, plus 6a3 equals 33, because I multiplied each of these terms by negative 3. And then we'll keep the other one unchanged. So then we'll have the a2's will zero out. We'll have 2 of the a3's, and that's going to equal to, let's see, 13 minus 4 is 9. And then 2 minus 1 is 1. So a3 will be equal to 19 halves. So now we can start back substituting. So if I plug in a3 equals to 19 halves into either one of these equations, I'll go ahead and do it to this one. So we had negative a2 minus 2 times a3 was equal to negative 11, but we found that a3 was 19 halves. So negative a2 minus 2 times 19 halves equals negative 11. So these 2's will divide out. So we'll get negative a2 is equal to, so adding 19, I'll get 8. So a2 will be negative 8. And then our next step will be to find a1. So a1 plus a2 plus a3 was equal to 1. So we'll use that one, that top equation. So then plugging in for a2, we'll get negative 8. Plugging in for a3, we'll get 19 halves, and that's all equal to 1. So a1 is equal to, let's see, 1 plus 8 is 9, and we'll be subtracting 19 halves. So a1 will be 18 minus 19 all over 2. So a1 will be, I just got a common denominator there. So a1 will be negative 1/2. Okay, so we have a1, a2, and a3. So what have we found? We found that the original equation, which was x squared minus x minus 8 divided by x plus 1 times x squared plus 5x plus 6 is equal to so a1 was negative 1/2, so negative 1/2 over, and that one, a1 was over x plus 1 over x plus 1. And then a2 was negative 8, so negative 8 over x plus 2 plus a3, which was 19 halves. And that'll be over x plus 3. So our whole answer is the sum of these terms. Okay, so yeah, that one was a little bit of a more mean system of equations, but pretty soon you're going to have matrices where you can solve these pretty easily on a graphing calculator, so it won't be as bad to solve the system. All right, so what if you have repeated linear factors? Well, you need to represent every possible power of that linear factor. So if the polynomial q has a repeated linear factor, say x minus a raised to the n, where n is greater than or equal to 2 and n is an integer, then in the partial fraction decomposition of p over q, we allow for the terms a1 over x minus a plus a2 over x minus a squared plus dot 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 plus a sub n over x minus a to the nth power, where the numbers a1, a2, dot, and then all the way down to an are to be determined. So here we go. Notice that our repeated linear factor is the x squared. So we'll have this is equal to a1 over x plus a2 over x squared plus a3 over x minus 2. So why don't you guys go ahead and pause the movie and see if you can solve this guy. Okay, let's see how you did. So we'll have x plus 1 over x squared times x minus 2 equals, so we're looking to get a common denominator of x squared times x minus 2. So the a1 is missing the x times the x minus 2. a2 is just missing the x minus 2. And then a3 is missing, good, the x squared. Oops, it's kind of a rough fraction bar there. Make this neater so you can read it better. Okay, so now that we have the same denominator, and I'm seeing that I'm going to have a squared term, and I don't have a squared term here on the left. So I'm going to say 0x squared plus 1x plus 1 equals. So a1 is going to be a1 times x squared minus 2 times a1 times x plus a2 times x minus 2 times a2 plus a3 times x squared. So factoring, we will have a1 plus a2 times x squared, and then the coefficients for the x are negative 2 times a1 plus, oh, I'm sorry, the squared terms were a1 plus a3, that's better. And then, let's see, negative 2a1 plus a2 are the coefficients to the x's, and then there's only one constant this time, so we'll have plus negative 2a2. So now we are ready to equate these. So the 0 will be equated here, and the 1 is equated to these, and the other one here is equated to this one. So this will be a much easier system to solve. So we will have a1 plus a3 is equal to 0. We will have negative 2 times a1. plus a2 is equal to 1. And then negative 2 times a2 is equal to 1. So I think this one will be easiest solved by substitution. So if you first take the bottom equation, negative 2 times a2 equals 1, and if you isolate a2, you get a2 is negative 1/2. And then what we can do is we can backtrack, and we can use our middle equation that we have negative 2 times a1 plus a2 is equal to 1, and we will substitute in the minus 1/2 for the a2. Adding 1/2 to both sides, we'll get negative 2a1 will be 3/2. 1 plus 1/2 is 3/2. And then dividing both sides by negative 2, a1 will be negative 3/4. And now we can substitute that one for our top equation, which had a1 plus a3 is 0. So negative 3/4 plus a3 is 0. So a3 is positive 3/4. So what we found out was our equation up here, which was x plus 1 over x squared times x minus 2 is equal to negative 3/4 over x, and then plus negative 1/2 over x squared, and then we get plus 3/4 over x minus 2. So there you go, your partial fraction decomposition for that one. Okay, the third case involves a non-repeated irreducible quadratic. So we put a constant over a linear factor, so it makes sense that we're going to put a line over a quadratic. So if Q contains a non-repeated irreducible quadratic factor of the form ax squared plus bx plus c, then in the partial fraction decomposition you allow for the term ax plus b over your ax squared plus bx plus c, where the numbers a and b are to be determined. So here we go. Notice that we have a quadratic factor, a non-repeated quadratic factor of x squared plus 4 and a non-repeated linear factor. So we'll have a combination. So let's just use, I guess, a, b, and c. So we'll have ax plus b over x squared plus 4, and then we'll have plus, we'll call it c since we're using a and b, over x plus 1. So now, moving on to do some work, we'll have 1 is equal to our common denominator is x squared plus 4 times x plus 1. So ax plus b, be careful to put parentheses around it, is going to be multiplied to x plus 1. And then our c will be multiplied to x squared plus 4. So notice we're going to have an x squared term and an x term. So I'm going to write 0x squared plus 0x plus 1 is equal to, and this was all over x squared plus 4 times x plus 1. So now that we have the same denominator, what we'll do is just work with those numerators. So that we're going to have ax squared plus ax plus bx plus b plus cx squared plus 4c. So 0x squared plus 0x plus 1 is equal to, so our coefficients to our squared terms are a plus c, and then our coefficients to our x terms look to be a plus b, and then our constant terms will just have b plus 4c. So this one I think will be pretty easy to solve, I hope. So the constant terms equal to 1. The coefficient to the x will be equal to 0. And the coefficient to the x squared is equal to 0 as well. So what we'll have is, equating the greens, we'll have a plus c is 0. Equating the blues, we'll have a plus b is 0. And then b plus 4c is equal to 1. So I suggest we work with the top two equations. We have a plus c is equal to 0. So a is equal to, do we want to isolate a or do we want to isolate c? I think we'll do a is equal to negative c. Oh, that's how we'll do it. We're going to work with the first and third because I'm looking that the middle one has a plus b. So we need to solve b in terms of c in that third one so that we can substitute in the middle. So the third one has b plus 4c equals 1. So b is 1 minus 4c. So going to our third step, we'll substitute in a and b in there for what we had in terms of c. So a plus b equals 0 gives us negative c plus 1 minus 4c equals 0. So that'll give us negative 5c is equal to negative 1. I got that 1 to the other side, so dividing we'll have c is positive 1/5. So now going back, a is negative c, so a will be negative 1/5. And then over here we had b was 1 minus 4c, so b will be 1 minus 4 times a fifth. So b will be 1 minus 4/5, which is also 1/5. So at the end of the day, what we ended up with was 1 over x squared plus 4 times x plus 1 is equal to 1/5 over, or 1/5 x rather, plus 1/5 over x squared plus 4. And then c was also a was negative 1/5, gotcha. So c is positive 1/5 over x plus 1, and we're all done. So the last case is where you have repeated linear factors. So let's check it on out. A repeated irreducible quadratic factor of the form ax squared plus bx plus c raised to the n, where n is greater than or equal to 2 and n is an integer. Then, in the partial fraction decomposition of p over q, allow for the terms a1 times x plus b1 over ax squared plus bx plus c to the 1, and then plus a2x plus b2 over ax squared plus bx plus c squared. And then you keep doing that till you're done, and you'll have anx plus bn over ax squared plus bx plus c raised to the n. And then, of course, a1 and b1, a2 and b2, all the way down to an and bn are to be determined. Okay, so here we go, right? The partial fraction decomposition. So we have x squared plus 16, it's quadratic, and it's raised to the second power. So this will be a1x plus b1 over x squared plus 16 all to the 1 power. And then we'll have a2x plus b2 over x squared plus 16 squared. Okay, so now we're working toward a common denominator. So I'm going to write x cubed plus 1 is equal to, the very first numerator is in need of one factor of x squared plus 16. So we'll have a1 times x plus b1, that quantity times x squared plus 16, plus a2x plus b2. That one already has the common denominator, so we don't need to make an adjustment. And this was all over x squared plus 16, the quantity squared. So now we can equate our numerators. And let's see, let's write it like 1x cubed plus 0x squared plus 0x plus 1 is equal to a1x cubed plus 16a1x plus b1x squared plus 16b1 plus a2x plus b2. Okay, so now gotta group them together. So we have a1 is the only one that's times x cubed. And then we have just b1 that's in front of x squared. And then we have 16a1 plus a2, our coefficients to the x, and then our constants will be 16b1 plus b2. All right, so let's see what we've got here. So now we have this was to our squared term. This is to our x term. This is to our constant term. And oh, we're running out of colors. Let's see. Do I don't know, different blue maybe. This one goes with the A1. So here we go. Let's see what we have going on. So A1 equals 1. That was easy enough. B1 equals 0. Then we have 16A1 plus A2 equals 0. And 16B1 plus B2 is equal to 1. So let's go down the line here. We've got A1 and we have B1. So here we go. We know that 16A1 plus A2 is 0, and we know that A1 is 1. So 16 times 1 plus A2 is 0. So A2 will end up being negative 16. Now, since we know that B1 is 0, we can go down to that fourth equation where we have 16B1 plus B2 is equal to 1. So plugging in 0, we'll get B2 is 1. So now we have A1, A2, B1, and B2. So here we go. So it turns out that x cubed plus 1 over x squared plus 16, the quantity squared, is equal to, so A1, that'll give us 1x plus 0. So we'll just get x, let's see, x over x squared plus 16. And then A2 we said was negative 16, so we'll get negative 16x. B2 is 1 plus 1 over x squared plus 16, the quantity squared. Okay? Okay, so one more, and then you'll be all done. I bet you'll be ready for a margarita after this one. I know I am. So the first thing one could look at is that, hey, does this guy factor? Does this guy factor? Well, factoring by grouping, you'd factor out an x squared from the first two terms, and you'd get x plus 1 remaining, and that wouldn't work with the 5x plus 3. So hey, why don't we use something we actually learned? P over Q, remember the possible rational zeros? So it's plus or minus the constant over plus or minus the coefficient of the leading term. So this would just give us plus or minus 3. So I'll just go ahead and try negative 3. So we'll divide. And then I'm just going to use synthetic division. So we have 1, 1, negative 5, and 3. So the 1 comes down, so we'll end up with negative 3. 1 plus negative 3 is negative 2. This will give us 6, which gives us a 1. Negative 3, hey, it worked. So what did we find out? We found out that the denominator, x cubed plus x squared minus 5x plus 3, is equivalent to x plus 3 times x squared minus 2x plus 1. And notice that last one can factor. So here is what we'll have. We will have x squared plus 1 divided by, we're going to write it in this form, x plus 3 times, do you guys see that second factor is x minus 1, the quantity squared? So that'll equal to a1 over x plus 3 plus a2 over x minus 1. And don't forget, you got to do a3 over x minus 1, the quantity squared. So this was all side work here. Okay. So now, here we go. We have x squared plus 1 divided by x plus 3 times x minus 1, the quantity squared is. So we'll have x plus 3 times x minus 1, the quantity squared. So A1 is missing the x minus 1 quantity squared. A2 is missing the x plus 3 factor. And A3 is missing the x plus 3 factor. So now that we have the same denominator, we can just equate the coefficients. So x squared plus 0x plus 1 is A1 times x squared minus 2x plus 1 plus A2x plus 3A2, and then plus A3x. Oh, you know what? The A plus 2, my bad. Do you see what I missed? It should have been times x minus 1 as well, because it was missing an x minus 1 factor. So let's just go through and fix that one. Okay. So we're going to end up having A2 times, when you multiply those together, you'll have x squared plus 2x minus 3. And then now we have our A3 times x plus 3 times A3. So x squared plus 0x plus 1 equals A1 times x squared minus 2 times A1 times x plus A1 plus A2 times x squared plus 2 times A2 times x minus 3 times A2 plus A3 times x plus 3 times A3. So x squared plus 0x plus 1 equals. So our x squared terms, it looks like we have A1 plus A2 times x squared. And then our x terms, we have negative 2A1 plus 2A2 plus A3 times x. And then our constants will be plus A1 minus 3A2 plus 3A3. Oh, that one was kind of a bear, huh? Okay, so our constants are going to be equal to this one. The coefficients to x are in blue, and the coefficients in x to x squared. Whoops, I forgot to write out the 1. So that's what we'll equate those two. So let's see what kind of system we have. So we got A1 plus A2 is equal to 1. And then we have negative 2A1 plus 2A2 plus A3 is equal to 0. And then A1 minus 3A2 plus 3A3 is equal to 1. Okay, so let's see what we should do with these guys. So, think if we go ahead and we already have one equation in terms of A1 and A2. So let's do this. Let's go ahead and we'll add the second and third equations, and our goal will be to eliminate A3. So we'll have to multiply the middle equation by -3. So that'll give us 6A1 and then minus 6A2 minus 3A3 equals 0. And then we'll have A1 minus 3A2 plus 3A3 equals 0. So then we'll get 7A1 minus 9A2. Oh, and this one was supposed to be equal to 1. Equal to 1. Those will equal to 1. So now I'm going to add this equation and our top equation, and we'll be able to solve for one of them. So we'll have, if I do the minus the top equation, so -1 times the top equation, I'll get -A1 minus A2 equals 0. Oh, I was looking at the wrong thing. Sorry, guys. It's been a long week, a long month. So if I multiply by -7 for the top equation, I'll get -7A1 is equal to 1. And then we have our equation over here where we have 7A1. And I'm sorry, that would be equal to -7 because we multiplied it by -7. So I'll have 7A1 minus 9A2 is equal to 1. So the A1 0 out. I'll have -16A2 is equal to -6. So A2 will equal to positive 3/8. And then back substituting, we'll go to our third one. We'll just do A1 plus A2 is equal to 1. So A1 plus 3/8 is equal to 1. That would make A1 5/8 because 5/8 plus 3/8 is 8/8. And then finally, A3 we can get by plugging into one of the other equations. So I'll just do the third. A1 minus 3A2 plus 3A3 equals 1. So we had 5/8 for A1 minus 3 times 3/8 plus 3 times A3 is equal to 1. So let's see, 5/8 minus 9/8 will be -4/8 plus 3A3 is 1. So 3A3 would end up being 4/8 is a half, so 1 plus a half is 3/2. And when I divide both sides by 3, the 3's divide out and I'll get 1/2. So at the end of the day, what we found out was x squared plus 1 divided by, I'll put it in its original form, x cubed plus x squared minus 5x plus 3 is equal to 5/8 over x plus 3. Let me make sure that's what my A1 was. Yes. And then our A2 was, where was A2? 3/8. So plus 3/8 over x minus 1, and then plus 1/2 over x minus 1, the quantity squared. Okay, and that wraps it up for today. Have a fabulous night and take care. Bye.